Assalamualaikum. This is a topic about statistics, measure of dispersion. There are three types of measurements for dispersion. First is range, and there's also what I call that interquartile range. And then this is the first one. There is a second one called variance. And the third one is called standard deviation. Okay, so in this lesson I will only cover these two, variance and standard deviation. Range and interquartile range is not in the scope of this presentation. Okay, I give you an example. I'll give you a formula first, alright? This is the symbol of variance, sigma squared. The first formula is summation of x minus x bar squared over n. This is the first formula. Second formula is also on variance. X squared, summation of x squared over n. Well, let me just get it corrected there. I get it nicer. Minus x bar squared. And the third equation, the third formula is this: summation of fx squared. Well, this is too big. Let me just adjust the size. Over the summation of f minus x bar squared. Let me just explain some of the notations. X over here means the data itself, right? And x bar is the mean, or we can also call it average. Sometimes mean is also being denoted by the letter mu, the Latin letter mu. So this is another symbol for mean. Okay, so just in case if you're at your school, the symbol is being used different. So in Malaysia, for example, x bar denotes mean. Some other place is probably being denoted by mu. And then n is the frequency, or cumulative frequency. Okay, the total frequency. So let's take a look at the first formula first. I'm going to show you example. Okay, this is variance. Okay, the other one, these are all variance. The other one that I promised to show you is standard deviation, right? Standard deviation symbol is sigma, the small letter sigma. This is standard deviation. In essence, standard deviation or sigma is actually equal to square root of variance. Variance. Okay, let me just get the spelling corrected. Okay, since variance is sigma squared, so, and as such, well, then sigma is square root of variance. Okay, let's take a look at how to how to use the first formula first, and what kind of scenarios. I'm gonna cut away this one. Alright. Say for example, a question like this: determine the variance of the set of data 9, 10, 8, 1, 4, 7, 5, 12. Okay, 9, 10, 8, 1, 4, 7, 8, 5, 12. So there are 8 numbers there. This is 10. Then we are going to use we want to find the variance, right? We can also, once we find the variance, we can also find the standard deviation. Very straightforward. So let's use this formula over here. But before doing that, we need to find all the other values, right? X is the data. This is the data. These are the data. Okay, the 8 of them, and then X bar. Okay, X bar is the mean. So X bar is not known yet, while N is known. N is frequency, which is 8. 1, 2, 3, 4, 5, 6, 7, 8. So N is 8. While X bar is something we need to find out. How do we calculate X bar? It's like this. Okay. Total up all the data there. Or we can also put the formula for mean is something like this. Okay. Total up all the data, and then divided by the frequency. So 9 plus 10 plus 8 plus 1 plus 4 plus 7 plus 5 plus 12 over 8. So, you know, because this requires a lot of calculations, so it's very easy to make mistakes. So this is very prone to errors, so do be careful. One mistake to the digits or mistake and during punching in onto the calculator will lead to the bigger mistakes. Alright, so please try to avoid mistakes in this type of calculations. Let's wait for my calculator to pop up. There you go. So 9 plus 10 plus 8 plus 1 plus 4 plus 7 plus 5 plus 12. Alright, there you go. It's equal to 56. Okay, so this is 56 over 8, which is equal to 7, right? Let me check. 56 divided by 8, 7. Alright, there you go. So you see, there are some numbers here. Okay, 9, 10, 8, 1, 4, 7, 5, 12. So the mean is 7. Okay, then I'm going to create some more space, some space here. So I shall save the data here. That X bar is equal to 7. I will delete the rest. Delete the whole thing here so that I can create some space. Then let's do calculate variance here. So variance is summation of X minus X bar. So what we need to do to get the data of all how dispersed the data is from the mean. Okay, so take a look at this. First one is 9 minus 7. So we take a look at the data 9 and see what is different, the difference between this number, this data, and the mean. Okay, and then we square it. Then divided plus 10 minus 7 squared plus 8 minus 7. Again, be careful, do not make any mistake. Plus 1 minus 7 squared plus 4 minus 7 squared plus 7 minus 7 squared plus 5 minus 7 squared plus 12 minus 7 squared. So this is very lengthy calculation. Be careful. Divided by 8. Let's do one by one. So 9 minus 7 is 2 squared, plus 3 squared, plus 1 squared, plus minus 6 squared, plus minus 3 squared, plus 0 squared, plus minus 2 squared, plus 5 squared. Okay, everything divided by 8. So this is 4 plus 9 plus 1 plus 36 plus 9 plus 0 plus 4 plus 25. Everything divided by 8. So let's use calculator. Four plus 9 plus 1 plus 36 plus 9 plus 0, okay, plus 4 plus 25. That is 88. 88 over 8. So that is equal to 11. So the variance is 11, and as such, this is variance. Okay. Standard deviation sigma is equal to square root of variance. Then square root of 11, which is equal to 3.317. Alright. Okay, let's go take a look at the second formula here. See how this is being used. Okay, this is the second one. Let's use the same data again, okay, from the previous problem. This is the one, and let's see whether or not it produces the same result. It's different, the formula is different, but let's see whether or not it gives us the same result. Okay, let's go and do it. Mean as we know it is equal to 7, right, from the previous example, and is 8. Well, mean is 7. Okay, let's just use it. So variance is equal to summation of x squared. I don't need to repeat that, right? So let's just continue doing it. Summation of all the squares of this data, so that is 9 squared plus 10 squared plus 8 squared plus 1 squared plus 4 squared plus 7 squared plus 5 squared plus 12 squared. So these are basically very large numbers. So if you feel that the first formula is more suitable for you, then just do it. Okay, this is quite large numbers to handle. So mean squared, okay, mean squared is 7 squared. So let's go and solve this. 9 squared is 81 plus 100 plus 64 plus 1 plus 16 plus 49 plus 25 plus 144 over 8 minus 7 squared is 49. Okay, let's go and check it out. Okay, 9 squared and 81 correct, and 10 squared is 100 8 squared 64, 1 squared is 1, 4 squared is 16, 7 squared 49, 5 squared 25, 12 squared is 144. It's correct. We have to do all that check continuously so that we do not make any mistake. 81 plus 100. Even keying into the calculator, you can make some mistakes, so be careful. So check out all the numbers that you key in. Plus 16 plus 49 plus 25 plus 144. Okay, so that is 480 divided by 8 minus 49. So that equals to 480 divided by 8. That is 60. Okay, 60 minus 49 is 11. So you get the same answer. So this is variance. And again, standard deviation sigma is square root of 11, which is 3 point something. I've forgotten. Let's check it out. 3.317. There you go. So whether or not you use this formula or the first one, it makes no difference. Okay, it gives you the same results. But let's take a look at how to use the third formula. So I'm going to take this formula then. Okay, how do we use this? Let's see. By the way, this formula is being used for group data only. This is for group data. Okay, previously the two formulas are being used for ungrouped. So this is used for group data. Let me show you what group data means. To do this, I shall use Microsoft Excel to illustrate. Okay, take a look at the question. The following table shows the number of books published in a year of 30 publishers. Take a look at it. Number of books between 50 to 99. So this is what we call group data. Meaning it's been grouped into few categories into one. Okay, few numbers into one category. So we round up the number of books that is between 50 to 99. Okay, and then 100 to 149. So it's multiple of 50, and then have 50 to 199, 200 to 249, 250 to 299. So these are the frequencies. Okay. Okay, I have highlighted before that that we need to have a summation of f x squared. Okay, what is f? F is the frequency, x is the data itself, and x bar as usual is the mean. Okay. So let's figure out what the means are by completing the tables. Oh, by the way, x here is not the same as the x that we know in the group ungrouped data, but x here is actually the class mark. Okay, I tell you what class mark is. For example, if a class is like a grouping, right? 50 to 99. This is the first group that we have in the example here, right? 50 to 99. So that's the first group. So this is what we call class. Is a class. Then class mark is actually the middle value. Is the middle value. Okay, so what is the middle value for this? So let's take a look at this. 50 to 99. It's actually written as 49.5. Okay, we are taking a look at. Okay, I shall explain a little bit further because it's a little bit difficult to understand. Let me pick up different one. Okay, let's take a look at the whole thing over here. Okay, all the classes available in this example. Let's take a look at this class, for example. Okay, 100 to 149, and let's go and determine what is the class mark for that. Take a look at the value here. Okay, this value is between 99 and 100, so we take that as 99.5. okay, the middle value, and then the middle value between 149 and 150 is 149.5. so what class mark is, basically class mark for this category is class mark for this class. Okay, this is actually 99.5 plus 149.5 divided by 2. Let's take a look at the value. Let's use the calculator. 99.5 plus 149.5. we are taking at the middle value for that class. Oh, wrong key in. 149.5. okay, that is equal to 249 divided by 2. so that is the class mark for that. 149.5, 124.5. okay, 124.5. so let's fill up the table in the Excel spreadsheet. Okay, I have rearranged the table in this way so that I can figure out what are the class mark and what are the frequencies, and then fx is the frequency times the class mark. Okay, for example, this one, what is the class mark for that? Let me just go and okay, readjust to make it nicer. So that is between 149. Let me just do some calculation here. This is equal to 149.5 plus 99.5, and we divide that by 2. Okay, that's 74.5. that's the class mark, and this one we have already figured out, but let me just do that again. 99.5 plus 149.5, and then divide by 2, which is 124.5. okay, this one is 149.5 plus 199.5 divided by 2. There you go. 199.5 plus 249.5 divided by 2, and this is 249.5 plus 299.5 divided by 2. There you go. Frequency, you just take a look, just fill out the value as in the table above. Okay, the frequency is 4, this class is 88, and then 11, 5 and 2. Okay, now what is the summation of the frequency? Summation of frequency is if you add up all those numbers, is equal to 110. Just hold on. Let's not do that yet, okay, because there's some contradiction in the book here. Let's just multiply class mark and the frequency first. Fx, okay, Fx means this is the class mark x, and then f, then you just multiply them together. So let's multiply 74.5 multiply with 4. That's the value you get. And I just drag this because if you are familiar with Excel spreadsheet, you can just do that, right? Just drag it. 200. Okay, there is something wrong here. This is not 88, but this is 8, so this is a printing error. That's no wonder there's a lot of discrepancy there. Okay, there you have it. So now it's correct. So this summation for all the frequency is actually 30. Okay, I just counted it. And this summation, let's take a look, is 4885. Okay, and then x squared is just the class mark, then you square it. So that's what you do, 74.5, and then you square it, and then you get 550. So I just drag the same formula. Oops. Okay, hold on, let me just get rid of some unknown object here. There you have it. Okay, so these are basically the square of the class mark. Okay, and then the x squared multiplied with the f. And again, I drag the whole thing. This is what I get. And what is the summation of all this? I can figure out from the screen over here that is equal to 883,857.5. Okay, let me just go and key in that number. 857.50. So that's it. There you go. Let's make it a little bit bigger. Okay, I will copy this table into the my blackboard, so for easy reference. I need to get rid of a few things here. Okay, let's put the table here. Okay, so this is the reference that we need to use. So now let's use the formula. After we get all this data and get it tabulated nicely, then let's go and use it. So again, the formula of variance is summation of fx squared over summation of f minus x bar squared. So what is x bar squared? What is x bar, first of all? Well, that is not settled yet, huh? So x bar is basically the summation of all the class marks. No, this is the formula for x bar, summation of fx divided by summation of f. So this is the summation, which is 4885 over 30. So when you come up with this measurement of a calculation of variance of the group data, that you need to come up with this table. So that is actually equal to, let's use the calculator, 4885 divided by 30. Okay, 162.83. Okay, we just take up to 2 decimal places. So now we can use the formula, okay, for variance. First, what is the summation of fx squared? That this is the value. So quite a big number there. 883.85 57.5 divided by summation of frequency, which is 30, that's the number, minus 16.83, 162.83 squared. Okay, let's use the calculator. Okay, we have the original value of the mean over here. Let's go and square it first. Okay, that's the value for 26,514 to 26,514. What's the decimal places? 26,514.69. Okay, and what about that? It's quite lengthy. You just need to go and follow the method and the formula. You should get the right answer, providing that you don't make any mistakes. Okay, 883,857 divided by 30. Okay, that's the number, and then you 39,461 point 9192. 92. So that is basically minus 26,514.69. So that is the answer. 2,948, 200, 2,947.2. 2947.2. So that is the variance. Okay, 2947.2. That is the variance. So so what is the standard deviation? Standard deviation is the square root of that. Okay, which is, use this value again. Can I do that? There you go. 54.3. Okay, so well, it is quite a big standard deviation for this one, 54.3. Okay, this looks a little bit intimidating. Yes, it is intimidating, I will not lie to you, but just follow the method, just follow the formula. I'm sure the formula is given in the formula sheet or on your question paper. Just go and follow exactly, but remember, you have to understand all the meaning of the symbols here. Okay, for group data and ungrouped data, they are all different in meanings. Okay, I hope Fadli, you get something out of from here. If you have any problem, just let me know. Okay, bye bye. Assalamualaikum.